So let's look at some different example problems where we're dealing with I raised to different powers. Or in other words, we're dealing with the powers of the imaginary unit. So which of the following is equivalent to the complex number I raised to the 22nd power? So I, remember, is just the square root of -1. And for these problems, it's helpful to remember the cycle. So I squared, remember we are just taking the square root of -1 and we're squaring that. So square and square root will cancel each other and we just get back -1. I to the third, remember, can just be rewritten as I squared times I. I squared is -1, so this just becomes minus I. And I to the fourth, that's really just I squared times by I squared. And we have -1 times -1, which is +1. And then it's going to go in a cycle. We looked at that both algebraically by just computing I to the fifth, sixth, seventh, eighth, ninth, and so on. And we looked at it geometrically on the complex plane, where every time we multiplied by I, we just went in a 90-degree rotation from where we were. So, for instance, we know that every time we increase the exponent by 4, we just end up back at the same place in this cycle. So I squared, we know that is just I to the 6th, I cube and I to the 7th are the same, and I to the 8th and I to the 4th are the same. And since I to the 4th is the simplest number in the cycle, we tend to use this to actually evaluate I raised to much higher powers. So for instance, I to the 22nd, the way we're going to approach this problem is to figure out what the largest multiple of 4 is that goes into 22. And the largest multiple of 4, closest to 22 but below it, is 20. So 4 goes into 20 evenly. So we can essentially pull that out. So I to the 22nd power is the same thing as I to the 20th multiplied by I squared. Since remember, we're just using exponent properties here. They have the same base, so we can add the exponents. Or in other words, we are multiplying I 20 times here, and then we're multiplying it 2 times here. So in total, we're multiplying I 22 times. So it's just another way to look at this problem. But I to the 20th, this is a multiple of 4, and so this is going to be equal to 1. Now, if you want, you can actually write this out explicitly, since I to the 20th is really just I to the 4th times I to the 4th, and we're going to do this 5 different times so that we actually have 20 i's here multiplied together, and then we have I squared. And then each of these I to the 4ths, that's just 1. So you get 1 multiplied by itself 5 times, and then I squared. And of course, 1 times 1 is just 1. And even if you do it 5 times, it's still just 1. 1 to any power is 1. So this is just I squared. And we know I squared is just -1. Now, instead of writing all this out, what we could have done is just written this as I to the 4th power and multiplied 5 different times I squared. And of course, I to the 4th, that's 1. 1 to the 5th power is also 1. So you still get the same answer. You still get I squared, and then I squared is -1. So to answer this question, it's choice letter C, -1. And let's do another example. So now we have which is equivalent to I to the 5th power. Well, we did look at that in the previous example, but let's use our strategy here. So we want to essentially pull out the largest multiple of 4. And 4, in this case, is the largest multiple of 4. So we have I to the 4th multiplied by I. And we know I to the 4th is just 1. So we get 1 multiplied by I, which is just I. And so choice letter B is the correct answer here. And let's keep going. We'll do another problem. So this one is I to the 30th. So we need to think which multiple of 4 is closest to 30, but below it. And 4 goes evenly into 28. So I to the 28th times by I squared is the same thing as I to the 30th. And 4 goes into 28 7 times. So we can rewrite this as I to the 4th to the 7th power, since we're really just multiplying I to the 4th 7 different times. Or when you have an exponent to an exponent, you can multiply these. So that's the property we're using to rewrite this expression here. And then we still have I squared. And we know I to the 4th, that's just 1. So 1 to the 7th multiplied by I squared, but 1 to any power is just 1. So we have 1 times I squared, and I squared we know is -1. So 1 times -1, this is just -1. So our answer here is choice letter C. And let's do one final question. So for this, I'll just make one up. Let's say we have I to the 59th power. Let me rewrite that 5. So we have I to the 59th power, and we need to first determine what is the largest multiple of 4 that goes into 59. So that would be 56. Since 4 goes into 60 evenly, so it's got to be 4 less than that. So we have I to the 56th power multiplied by I to the 3rd, since these add up to 59. And 4 will go into 56 14 different times. So I to the 4th raised to the 14th power, that's equal to 56 here. And we still have our I cubed left over. And we know I to the 4th is 1, so we have 1 to the 14th power multiplied by I cubed. And 1 to any power is 1, so we get 1 multiplied by I cubed. And if you forget what I cubed is from the cycle, you really just need to remember the two main ones, that I is the square root of -1, and when you square a square root, they cancel each other, and we just get back -1. So back to this problem, with I cubed, that's really just I squared multiplied by I, and we know I squared is -1, so this just becomes -I. So it is possible to raise I to very large powers. The difficulty just comes in figuring out what the closest multiple of 4 is that's less than that power. And in this case, 56 was the closest to 59 without going over it.